This VI performs the useful service of converting a one-dimensional bit stream into an array of k-bit words, or you could call them k-bit blocks if you like. You can see how I'm setting up the one-dimensional Boolean array for my bit stream input. And the reason we like to have these organized into a 2D array is that for subsequent processing we can get easy access to each of the k-bit blocks. The critical LabVIEW node for this purpose is Reshape Array. Let's find out how this works. Now you can connect the input array and then pull down on the bottom of the node to expose as many inputs as you might need. In this case, we're trying to convert it to a 2D array, so we only expose 2 inputs. In principle, though, you could define something like a 5-dimensional array if you like. Now, just to illustrate how this works a bit, I'm going to set up some specific values for the input bit stream. Realize that when you're doing this yourself, you don't need to do this step. You can just leave the control as it's been created. So I'll define some front panel controls for these 2 dimension size inputs. And let's experiment a bit just to see what the input-output behavior is for this Reshape Array node. Now notice that as long as one of these dimensions is 0, you don't get anything as a result. 1 by 1, we get 1 value coming out the other side. Here we have what appears to be a column vector, 4 elements long. There's a row vector, which is 5 elements long. So it appears that the leftmost control, called dimension size, is controlling the dimension vertically, and the other is controlling it horizontally. So we would normally look at this result and call that a 2 by 3 array, or a 2 by 3 matrix if you're thinking about it that way. So that way you have a better idea now of how to use those controls. Now another thing you're trying to do with this subVI is automatically do the reshaping based on only the parameter k for the word size. So what we need then is to know the size of the incoming bit stream. Actually, I'll temporarily remove that thing. So once we know the size, then we divide by k to find the total number of rows that need to be generated in that 2D array. So I'll draw your attention to this divider, especially the one that's doing the quotient output.